everybody. Today we will discuss next topic in big data, NoSQL database. It comes under the unit 4, NoSQL database. In RDBMS we studied SQL databases, but in big data we will discuss NoSQL databases. What were the problem with the traditional RDBMS? In that RDBMS, we should know the entire schema up front. Every record should have the same property, rigid architecture, rigid structure. Scalability is costly. Transaction and joins are expensive when running on a distributed database. Many relational databases do not provide out-of-the-box support for scaling, normalization, fixed schema, make it hard to adjust with the application need. Horizontal scalability is a problem, and SQL was designed for run on a single server system. So these problems are trying to remove in NoSQL. So NoSQL definition contains next generation database, mostly addressing some of the points. It is being non-relational. Non-relation means it is not in the tabular form as row and columns and tabular structures there in the RDBMS, and predefined schema is defined before creating the database. So in NoSQL there is no need for predefining the schema. It is distributed, it is open source and horizontally scalable. Single server architecture in the SQL, one server is there and number of clients. Why the single server architecture was not good enough? Because it contains high load, failure, single point of failure. Maintenance down is problematic because downtime during manual maintenance. The solution is distributed database. In the computer network, a number of servers are there, and each server is having its own database. Advantages of distributed server system: speed, files are retrieved from the nearest location. If one site fails, the system can still run. And disadvantages: the time for synchronization of multiple databases and data replication. NoSQL definition, we have already discussed. Benefits of NoSQL, these are the same thing. Then comes the next point, the types of NoSQL databases or NoSQL categories. 4 types of NoSQL categories or databases are there. First is key value stores, key value database. The second is document database. Third is graph database, and fourth is column database. So first key value database. In this, the database comes in the form of key value pairs. First is key, that is user 1, and value of user 1 is Mike. Key is user 2, value John. Example of key value database are Redis, React, and Oracle NoSQL. Second is document database. Document database. Documents are composed of field and value pairs and have the following structure. Document can contain many different key value pairs or key array pairs or even nested documents. Field 1, value 1, field 2, value 2, field 3, value 3, field and value 1. Example of document oriented database are CouchDB, Cosmos DB, and MongoDB. So MongoDB is the example of document oriented database. This is the structure of document. As in RDBMS, we call each row a record. In HDFS, in a document oriented database, one row is called a document and the table is called collection. So a collection of rows in RDBMS, we call it a table. In same as in NoSQL document oriented database, the collection of document is the same as the table is the collection of rows. Graph database are NoSQL database which use the graph data model comprised of vertices which an entity such as a person, place, object or relevant piece of data and edges which represent the relationship between two nodes. Then comes column family database model, fourth type of NoSQL database. Column family database are probably most known because of Google's book table implementation. They are very similar to on the surface to relational database, but they are actually quite different beasts. Some of the different is storing data by rows, that is in relational, versus storing data by columns in column family database. Means in row oriented database means in relational database, when we save the database in the memory, each row is row by row we store in the memory. Means one block of memory contains first row, second block of memory contains second row. But in column oriented database we store the table as a column. Is in column we store column wise. Means first block of memory contains first column, second block of memory stores second column. But a lot of difference is conceptual in nature. You can't apply the same sort of solution that you use in the relational form to a column database. Sample, row ID will be given for each row, but in the relational database column ID is assigned for each column. Cap theorem. This is very important theorem, as relational database follows ACID property. In the same way NoSQL database follows cap theorem and Bayes theorem. What cap theorem says? Eric Wierer's cap theorem says that if you want consistency, availability and partition tolerance, you have to settle for 2 out of 3. Means for a distributed system, partition tolerance means system will continue to work until there is a total network failure. A few nodes can fail and the system keeps going. So what cap theorem says, that if you can't achieve consistency, availability and partition tolerant all three at once. How? For example, if we say these are the 3 servers or bank servers, you can say if in first server database the value of variable is changed from 100 to 200, so 100, but it will take time to change the same transaction in the other servers also. So the data is available on all the 3 servers, but the correct data is available. It is not guaranteed. So we can achieve availability, but consistency at the same time we will not achieve the consistency. So if the example of the data that is always available is Facebook, we will get the data all the time, but it is not consistent data because not the correct data. But in bank server also, bank server is we can say it is the example in which we will get the consistent data, available data and partition tolerance data, but not all 3 properties at the same time. Then Bayes property of transaction, it is also the Bayes theorem, we can say it is the property of NoSQL databases. Basically available, BA stands for basically available, failure will not halt the system. So S stands for soft state of the system will change over time, and E stands for eventual consistency, means it will become consistent over time, or the system will become consistent over time. Difference between NoSQL and relational database, performance of NoSQL is high, relational is low, reliability NoSQL is poor, but of relational the reliability is good, availability both having having this feature means good. NoSQL is also good, and relational is also having good availability. Consistency is poor in NoSQL database. Relational is having good consistency. Data storage optimized for use data. It is for medium to large. Scalability is high in NoSQL. It is high but more expensive.